Hey everyone, welcome back from lunch. Hope you had a good one. And for the next half an hour or so, I'll be talking a little bit about at Motorway, how we've shifted gears, moving from events to an event-driven system. So as James mentioned, I'm Ryan. I'm a principal engineer, really big on there. I don't have a screen at home anywhere near that size, so this is life size now. I'm a principal engineer at Motorway. I've been here for about a year now. I'm also an AWS community builder. I've been building on AWS for over 10 years now, building serverless and event-driven systems there for 5 or 6 of those. So what are we talking about? How Motorway, where we started, where we came from. We actually started as a price comparison site for cars 5 or 6 years ago. So a lot of this journey is going to be how we've moved and starting to transition our business model into where we are today. How we built a system that had events, but it wasn't an event-driven system. I'll speak a little bit about what the differences between those two things are, and some of the changes that we've been making recently to start to drive out what a true event-driven system across our platform is. Some of the changes that we've made, not just within engineering, but across the rest of the organization, and some of the benefits that we've got. We're now living life in the fast lane, and how events are helping us really move at pace. First, what is Motorway? So I mentioned about 5 or 6 years ago, we started life as an online price comparison site. But since then, we've become the UK's fastest growing used car marketplace. So on average, a sale is agreed through Motorway every three minutes. And throughout our history, we've sold over 500,000 cars through our platform. And our platform is really a two-sided marketplace. We have people who want to sell their cars, and we have dealers and dealerships at the other side who are bidding to buy cars from people. We've started to build a lot of our event-driven systems around some of our core car profiling journeys, some of our car valuation systems, to really help give our customers the best price they can get when they're selling their car, but also build that trusted relationship with our car dealerships to make sure that they know that they're getting a really great service from us and some of the cars that we're selling. So some of our scale in 2023, we had a GMV of £2.7 billion. So we're selling really high value products through our platform. And EDA and some of the changes that we made have really helped us continue to accelerate this growth. I think it was only last week that our payment system that we had built to help facilitate some of these car transactions celebrated its 1-year birthday. Very cool for us. But over that year, they've processed over £1.2 billion of payments have started to go through some of these systems that we're building. So whilst we're selling cars, we've got a lot going on the side, some of it really nice, high value. So started on Heroku. Heroku was really great. It allowed us to scale really quickly. Business was still finding its market fit, and it allowed us to move it really agile, fast-paced to find where we wanted to be. Generally, we tend to build things in a lot of these open source systems that we've got there. So things like Postgres databases, RabbitMQ queues, and our container-based compute clusters. Then as we started to find the need for some extra things, we started to move off of Heroku and onto AWS. Elastic Beanstalk was a really great fit for us there. Show of hands, has anyone used Beanstalk before for anything? A couple of people. It worked, again, kind of well for us for a while. It allowed us to get off of Heroku really quickly and continue running the platform and continue moving our growth. At the same time, we continued to make use of things like RDS, and we're starting to use more RabbitMQ, and I'll get onto that shortly. Then a couple of years ago, there were some major changes across the world, and we started to see some really explosive growth. Things that the Beanstalk platform wasn't working quite so well for us, so we had to quickly move off of that onto some different compute that would help us to continue growing. So we moved to Fargate. It's been a really great fit. We're continuing to grow the rate and the pace that we need to, but we have continued to have more events across our system. And careful choice of words there, that we are continuing to, there are more events there, but we're not necessarily seeing these event-driven patterns coming out. Continue to want to grow with large features and systems, so the business rate of change has continued to grow. I mentioned we've a 1-year anniversary of this payments product that we've got, and over the last couple of months, we've started to launch more and more new features and services for us, and we want to continue that pace, and this is where some of that event-driven nature has come in for us. But we did also see an ever-increasingly big synchronous dependency chain across our platforms. And I don't think that's uncommon for really high-growth startups to start to see more HTTP requests happening within systems for any given user journey, and it started to become quite problematic for us. So we've got a typical system that we may have. Over the years, it may have started off with a web service with a database, pretty common, I guess typical of a lot of services. And then over time, we would add a little bit more in. We've got our profiling system right at the start. Our customers wanting to profile their cars to sell it. We're getting some information out of our profiling database. But we might also want to present the customer with some information about cars similar to this that dealers have recently bought. So we now want to make our synchronous request into our dealer service. We might want to filter some of those. So we're going through a search service that we've got. And as you can see, that we're starting to add more and more and more of these. The slide isn't big enough to show some of the synchronous hops that we've got in places. But I think it wouldn't be uncommon for a lot of people to see similar patterns across places. So we're starting to get these dependencies. There's a lot of temporal coupling happening here. If the dealer service goes down at any point, then that becomes problematic for search. It might become problematic for profiling. And we don't want to be in situations where there's a problem with a bug maybe in the dealer system, and now suddenly people can't profile and sell their cars. These should be two isolated and independent parts of the platform. So to get around this, great. Let's start using some asynchronous events. So we find ourselves using RabbitMQ here. It's an open source broker, powerful, it does a lot of things for us, and we put it in the middle of some of our services. So we've now got our services communicating asynchronously with each other. You might think, great, we've fixed the problem, we've got events, and we now have low temporal coupling between things. But when we started to implement these, we ended up with a system that had events but wasn't event-driven. And what I mean by that is that we had really, really good intentions for this. We know how to solve some of these problems. We want to reduce that temporal coupling. But without a strong strategy and plan of how we start to introduce these and move them and break the synchronous call dependencies that we've got here, all that we're doing is adding some of this extra complexity around the place. So we're in a situation where there are events going over our RabbitMQ broker, but no one really quite trusts them. Are they really working at the other side? Are people treating with the same sort of care and attention that we might do with synchronous HTTP requests? If we ever get errors, people get paged, we want to see what's going on. But we didn't always find those same things happening with our asynchronous processes. So sometimes, if the dealer service isn't processing the events properly, we end up with state mismatch and our system's out of sync. So we'd build a resync service. Every day, it might read some data from the database and move it into a different database to get around the problem of our events not really being respected everywhere. So we end up with these sorts of patterns starting to grow across the company. And whilst it's great, we have events, but we are not becoming an event-driven system. All that's happening here is that we are pushing events onto our bus, and then we're fixing the problem retroactively later because we have events without trust or purpose. We've fallen into this trap where we're starting to do it to think it will get us out of our problem, but it hasn't really. We don't have strong awareness of what events are going on here. There are certainly times where we might be publishing our database schema changes. This database table has updated with this data in it now. Put that onto the broker and off it goes. And now we've got our database schema starting to leak out across different systems. And these aren't the sort of decoupling that we want between everything. We'd sometimes build things with a lack of dead letter queues. Something breaks, you want it to go onto a dead letter queue, become notified from it, and rectify it, try and recover from that problem. We were finding, rather than trying to replay these events or understanding the state mismatch we might have, we would just run our resync service, and it would copy data from here and move it over here, and everything's good again. Which ends up with problems like this. So some of our RabbitMQ clusters, we've got 46,000 items on an undelivered queue. These are 46,000 or 45,000 events that have now broken across the system. There are other consumers of these that may want to have known about some of these events, but they don't. They're sitting on a dead letter queue or an undelivered queue somewhere. So that's where we start to feel that pain of having events, but it's not event-driven. So what is an event-driven system? An event-driven system or event-driven architectures use events to trigger and communicate between decoupled services, and it's common in modern applications built with microservices. An event is a change in state or an update, like a car being listed or a car being sold on a marketplace website. So this is actually taken from Amazon.com, their definition of an event-driven architecture. But there are a couple of really, really key points here that they're publishing the state changes that have happened. They're facts. Something like a car sold or a car being listed is an example of an event, something that we would want other business processes to react to. So events are facts. They're statements of truth, something that has happened in the past that we can react to in something happening. And events allow for low temporal coupling. When we publish events, we don't need the producer and the consumer to be available at the same time. We want to make sure that these aren't time-bound. Something can process information later on. And we've got an example later of how this low temporal coupling has already started to help us recover from some scenarios. An event can have many consumers. The fan emoji is the best one that's available for this fan-out pattern, fan-out process. And we'll see this come up a couple of times, but events do have many consumers. There might be multiple systems across the motorway platform that cares when a car is sold. So we can fan that information out and have many systems react in response to that fact change happening. So we've got an example of what a payload might look like here. And a lot of the information in here, things like the user ID and the vehicle, it contains all of the information about the vehicle that has been sold, something that's happened in the past. This has happened. It's got some information about who's bought it, and it might have some information about the sale date that's happened. And this is an example of using an event carried state transfer pattern, but we're able to put all of the information about that event into our payload and broadcast that out across our whole platform. It means that anyone across the motorway system can start consuming this event and do anything that they need to with it. And on top of that, it allows people like our data teams to start consuming all of this information in near real time, and we can start to build up really, really interesting data patterns and profiles and build on top of this. So we've got events, but we're not event-driven yet. We've got either a coupled monolith or a distributed monolith that's temporally coupled with each other. We've got those synchronous requests. Everything needs to be available all the time. We might have some events around the system, but there's a lack of trust or a lack of confidence about whether or not they're actually being used or how they're working. Are they working properly? Are they publishing facts, business process state changes, or are they publishing some of our database updates that have happened? We want those publishing the facts and have that low temporal coupling that we get from some of these benefits. So, spoken a little bit there about what it might mean to have events, but not to be event-driven. So what have we done to try and change it, to make the company become more event-driven? So I think some of the key bits that I want to touch on here, and themes I think might be coming up again and again today with some of these things that we can do to make event-driven architectures work, is we want to start with some event storming workshops. We'll look at how we've done some of these. We want to understand our technical boundaries, our business boundaries, and our bounded contexts, and then understand the changes in concept required across product and engineering teams. It's really, really important, and I want to stress this a lot, that becoming event-driven isn't just a technology change. We've found it to become like a change in mindset across our product and engineering teams, buy-in from the business to understand all the benefits that we get out of it, to make sure that we don't fall into that trap of having accidental events again. We want to have this strategy and plan in place to make sure that we continue to get the best we can out of our EDAs. So first up, event storming. I think it's been mentioned a couple of times already today, but event storming, rapid group modeling process to domain-driven design. We got, I'm going to say everyone, we got a lot of people together to do this. These sorts of systems only work, processes only work if you have product and engineering teams working together. We went one step further. We had product engineering and some of our key business stakeholders involved in this to make sure that we really understand everything. And part of the event storming process is we want to model out all of the business processes that we happen across the company. All of these facts that might be changing, all of these state changes that happen, and all of the processes that we've got for us to really understand where our event-driven architectures might start to come out. So we've got the team. There's a lot of post-it notes on here, and we spent good part of a day, afternoon. We probably haven't finished everything, but we wanted to get that really high-level process and understanding of everything that's happening. So we're all working together. I'm going to say together. This was really interesting, I think, that I mentioned that we had product, engineering, and business all working together here. And we started to see some discussions, some people might call them debates, other people might call them arguments, around what's actually happening with parts of our system. Because it's grown up over 5 or 6 years, bits of it have started to evolve, and people may have different understandings of what's happening or what's triggering different processes across the company. So we put it all on whiteboards or with post-it notes, and we start to see our domain boundaries. We start to see all of these business processes that are happening. And whilst we may think we are aware of them all in our head already, seeing them all mapped out like this makes it really, really easy for us to start understanding which bits of the system to tackle, which bits may have the most complexity that we want to try and unravel, and which bits might be good targets for us to start becoming truly event-driven with. So moving on from that, we've got that big picture. We've got the group level, the big picture architecture or processes of Motorway defined out. We start with understanding, getting a bit closer, trying to identify these smaller business domains of bounded contexts. So each one of those parts of that post-it note started to form individual parts of the business that we probably knew already existed, but we could start to rally around and identify bits where we really wanted to go hard with things. And then we started to get even closer down to the design. So starting to think about the architectural processes, changes that we may have to make to an individual piece of code, individual domain that we'd start changing first. So what did we come up with? This is an example of how some of that modeling resulted and what we wanted to take away from that. But we started to see some key boundaries domains. These aren't the specific ones, but I think they're representative where we've got these profiling systems. We want the profiling system to work independently of every other system. We run a last mile transport delivery part of the business to deliver cars to our dealers. We wanted to make sure that that could run independently. There was no temporal coupling and no synchronous requests to other parts of the system. And then importantly, I think what we're all here today to understand a bit more is like what we actually do with the events. We want to put all the events into our event bus or router and make sure that any other part of the business can start to understand them. So for us down at the bottom, really, really important that we've got this shared event bridge across the whole company that anyone can start to consume some of these events from. So we've got all of the synchronous north-south traffic within a bounded context, and all of the east-west traffic that we've got all going asynchronously. Any part of this has been driven by an event or a fact change that's happened to trigger another business process somewhere. So we might have a vehicle sold event happening, and that could send an asynchronous event to our transport system, so we can now start processing that transportation flow that we would need. And none of these things depend on any of the other systems to be up at any time. The world is asynchronous. I think Werner Vogel's, the Amazon CTO, has been quoted a few times today already. I'm going to put another one here from his reInvent 2022 keynote. The world is asynchronous. It's audience participation time. Who's had a coffee from the serverless espresso booth today? A lot of people. It's an asynchronous process. Everything that we do, most things that we do with most parts of our day-to-day life are asynchronous processes. And in reality, most of our software are asynchronous processes too. We want to build our clients so that so that we're building them in a way that they don't expect an immediate response from anything. If you want to book some transport, if you want to make a payment for a car that you've just bought, if you want to profile your vehicle, we want all of these to start a process, and then asynchronously, we can build our applications on top of that, and then return the response to the client in the end. The clients could be mobile phones, it could be web browsers, or they could just be different back-end services that we've got, but none of these processes are expecting an immediate response of the full information that we've got. So polling and sockets are great. Really, really both good front-end technologies. They make it really, really easy to get these asynchronous responses and push them out to our end-user mobile applications. Polling works well for a lot of these. Sockets work great too. And likewise, we can build things up. A lot of our systems, people might be taking photos of cars where they've got poor connectivity. So we want to make sure that the next time that user comes online, we're able to then asynchronously push a lot of information out to them. It doesn't matter if they lose connection at some point, it's fine. We've got the request stored up in the back end, and when they next come online, we can start to asynchronously feed all this data back to them. It allows for easier plug-and-play modular systems. I mentioned that by building these event-driven systems, we're able to easily plug all of our data into them. When we publish these event changes or facts that happen, the data team can slurp up greedily every state change that's happening across our system now and start to see trends that we've got, start to understand a lot of the processes that are going on, and they get it a bit more real time. They don't have to come along and query our database every X minutes. The data is just available there for them on demand, But it also allows us to start plugging in extra parts of the system every time we want to do something. Anytime we want to build a new product, the event is there. They don't have to think, what API do I have to call? They can just hook into our event bus, and they can start to process that data exactly when they need to. So there are a couple of the key bits there for the changes that we made to become event-driven. Events to involve the experts. These are the key business stakeholders that we've got. It's our product teams and it's our engineering teams. Working together, we're able to understand what it is that we need to do to start becoming more event-driven. We need to identify these domains, our bounded contexts and our boundaries, and understand our communication patterns between them. We don't want to be coupled to other systems outside of our domain. We don't need to make sure that they're always available for us to be able to run. And think async. Everything is async. The world is async. We want to plan for async communication. We want to implement async communication across places. Mentioned a few teams there. We've got our product teams and our engineering teams, our business teams. It is all about the teams. So a lot of this, whilst the implementation detail is a technical detail, the actual process of getting there, it's a team process and it's a team problem. So empowered teams build things faster. People don't have to be reliant on other teams to do things. People are able to just see the data that they want and work with it exactly when they need to. We don't have to have large multi-team sessions to understand who needs to change what part of their system to build something new. We're able to iteratively build and build fast and build in a decoupled, isolated way. We can start to build evolutionary architectures on our data without being coupled to the existing systems that we've got. Learning and experimentation is really key. So one of the best benefits that we get out of this is that we can start to experiment with new systems. We can start to bolt on extra services at the side without having any impact to any of our key critical components that we've got. It would be really, really bad if we wanted to try and build something new, and maybe a new business product, something that we've never tried before, and we've got to make large invasive changes to some of our core systems. We don't want to bring the platform down trying to experiment with something new. We want to build everything as isolated as we can. And start small, one team at a time. We don't like big bang releases with, I think, pretty much anything. We want to be releasing code iteratively and quickly all the time. It's the same for this. We don't want to change the entire platform to become event-driven overnight. It's hard to do. It probably wouldn't work very well, and it would almost certainly go wrong. So we want to find one system at a time. We want to start running minimum viable migrations, changing the smallest bit that we can, getting that feedback as quick as we can, and iterate on it as quick as we can. There are definitely times where we'd come across one- and two-way doors. So I think a common term, two-way door is something that you can go through. If it hasn't worked, you can revert and come back as quick as you need to. And a one-way door, should I go off? Batteries, redundancy. We've got a backup though. Oh, I'm back. So yeah, so we've got a two-way door, something that we can change easily. We want to change it really, really easily. We want to just go if we know we can revert it later, or we've got a one-way door. If you go through a one-way door, they're very, very hard to back out from. So
two bars, so it should be okay.
Thank you. So when we're finding things that we can change quickly, we just want to go. We want to start changing and building, knowing that we won't get it right the first time, but knowing we can easily change it if we need to. And then those other things, these one-way doors, when we come across one of those, we wanted to pause a bit more and take a bit more of a structured approach to it, because these things were going to be much harder for us to change. And importantly, one thing at a time, we don't want to stop everything else the business is wanting to do to try and say, we want to change this technical problem. It's never going to work. It's going to cause frustration. And again, it's not going to look good because you will do it wrong. We can't get everything perfect. So we want to iterate quickly, one thing at a time, and continue to grow the rest of the organization as we're moving. So what did we do? We want to teach the teacher. Find that one team of really, really hungry engineers who want to change things quickly. There may well be people who have done this before, experiencing it. There may well be people who are already trying to do these things internally. Find that team, embrace it, and make sure that we're able to learn and iterate quickly with it. It's really, really important that we're sharing the knowledge that we're getting. It's never going to work if we do all of this, and great, we've done it, we're great, we've got an event-driven system over here, and no one else knows about it, and then we're going to make the same mistakes again when someone else tries it. So we really want to make sure that we're embracing that internal knowledge sharing culture. We may run lunch and learns, we may do internal blogs, we may run internal workshops. We may lean on partners like AWS to come in and help us run some more workshops with the rest of our teams too. But we want to find something, we want to find ways to help everyone not make the same mistakes again. And that starts to increase the velocity all around. We find patterns that are coming out, we can iterate on those patterns, and we can make those patterns easier to run everywhere else. Every time we see a team wanting to do the same thing that another team has done, we've spoken about those learnings already. We can start to modularize it or share it if we need to, or we can help to make sure that we're not breaking things in the same way twice. And we want to lean on the cloud. We're here EDA day today. There's a lot of people, I guess, already using the cloud, maybe AWS, given where we're speaking, but we don't want to be redoing the things that they've already done. I can't imagine there are many people building clouds right now. We're not a car marketplace. We don't want to be building bits that the cloud has already built for us. There's a huge amount of undifferentiated heavy lifting, everyone's favorite cloud buzzword, that someone else is really, really good at. We want to make sure we can focus on building our products for our customers. So the cloud isn't just a fancy data center. If you take everything you've got in your data center and put it on the cloud, you're going to end up with a really expensive data center. We want to make sure that we're embracing the very best things that the clouds have to offer. And quite often we'll find that vendor lock-in tends to be a feature, not a bug. If you embrace it and use the best bits that you can from it, you get a lot of benefit coming out of there. You don't have to build a lot. Someone else runs it for you, and you can get to the point where you're starting to write only business logic code, code only. You don't have to do a lot. The other great thing about this, it starts to touch into that serverless side of some of these vendor-specific services, is that you get into a model where you pay per use. With systems that are waiting all the time to be told to do something, some of these synchronous systems, we might find that we're paying for it 24/7, when in reality, we're only processing 10, 100,000 things a day. We want to be reacting to events that have happened, and we only want to be paying money when something happens. We want to be building our services as cost efficient as we can, so making sure we're getting the best value for money that we can. So we want to pay per use as much as we can, which again leans really heavily into the async native nature of a lot of these services. A lot of them are just built by default to respond to asynchronous processes. The world is asynchronous, so is your cloud. I think we should embrace it. So some of the things, the patterns that I think go from a really cloud-native asynchronous process down to some that maybe less so, but we can use DynamoDB streams to help embrace this. You write your DynamoDB table, you don't have to worry about then also emitting your event or publishing it. DynamoDB will natively stream that straight out for you. You can stream it straight into an EventBridge pipe and then publish your business event out to the platform. Remember, we don't want to be publishing database changes, so we want to make sure that we're transforming that DynamoDB stream event into a business event or a fact that we can publish. Got that fan icon back again. Once your event is onto EventBridge, it allows you to really easily fan that out to different systems and services. We may have a car sold event, as an example, that lands in our event bus. We can then fan that out and have multiple queue consumers and start to process and consume that queue as much as we want to. Now, with this, the only bit of, I'm going to call it application or runtime code that we have to write here is inside the Lambda function. Once we've written to the DynamoDB table, AWS take care of publishing that to the stream. The EventBridge pipe takes care of transforming that to a domain event. And putting it onto EventBridge takes care of fanning it out. And our SQS integration takes care of subscribing to that event. And there's a bit in between the Lambda function and the queue that takes care of pulling the queue for us. So we cut out a huge amount of that undifferentiated heavy lifting that we've got to focus on our business events. And it's also all pay-per-use. If none of this is running, if we're not processing any events, there is no cost for us. So it allows us to scale in a really efficient way. And then finally, a pattern that we're starting to use more and more too is an outbox pattern. There may be times where something like DynamoDB may not be suitable for what you're wanting to use it for, and you want to just use a Postgres or MySQL database. That's fine. We can still write our information into our RDS database, but in the same transaction, we can also write an outbox event. This is the event that I want published. And then we can have our Lambda function polling that database or having a trigger off so we can then publish that event out into the rest of the world. It gets away from these two-phase commit complex problems where if we write to our database, but the event publish fails, what do we do? In some places, that might not always be a key consideration, but some of our use cases where we might be wanting to publish an event to say that we've sold a car for £50,000. If we write that into the database and the event publish fails, we've got a large problem there that we want to get away from. So this allows all of our processes to work atomically. And the two-phase commit, or this outbox pattern, makes a really, really nice event-driven system. The thing that's writing into the database doesn't care about publishing our events. Our Lambda function that's reading from the database, it can publish fan out, write that into EventBridge if we need to, and have that fan out to multiple consumers. We want to communicate with events. So I mentioned that we want to make sure that we're publishing facts on our business process changes. We're not publishing database schema changes. We're not publishing internal domain terminology in places. In David's keynote this morning, he had an example of publishing a reason why the order was cancelled with TW. What does TW mean? I'm sure the internal team know, but we don't want to be publishing internal domain knowledge. We want to be using ubiquitous language across the company to publish representations of our facts and business processes that have changed. We want to make sure that we're using our event storming because that should give us the information and understanding of what that we've got. We regularly refer back to these sessions that we've run months ago to understand where it was that we were wanting to go and how it is that we want to get there. So the all about the team, so we want to empower teams. Remember, empowered teams who can work independently of each other can move faster. People who don't have to be reliant on other teams to make changes to their systems and services scale independently. Oh, I want to launch my new feature. I need to remember to ask that team to scale their API up. It's ready for my launch. We want to be independent of each other. The cloud is not a data center. We want to lean on it. The cloud is a set of tools that we can use, and the cloud is really, really good at helping us build event-driven systems. It's really good at helping us build pay-per-use serverless event-driven systems too. And we want to communicate with events. Events are a contract. I think most people, we tend to be really, really familiar with the idea of we don't break contracts, we don't break our APIs, we have no breaking changes. Events are no different. Previously, we may have had our event schemas changing quite often. It's a pattern that we really want to avoid. We want to make sure that events are the API, the programming interface that we communicate with the rest of our systems and services through. We cannot break these. And really, really important that with your events, there are no breaking changes. If you need something new, you need to version your event and build something forward. I mentioned the business. Everyone's got a business. They're the people who are important to everything that we do day to day, and we need to make sure that the business is brought along for this. Again, these aren't just technical changes that we're making. The implementation is technical, but everything supporting it is to empower and grow the business ultimately. So a representation of Motorway's growth over the years. We started off down at the bottom left, and we've moved up through time. We've got some really, really fast growth. We've got loads of new features getting built. We sprinkle in some of these events that I spoke about at the start. There's no purpose, trust, or strategy direction with them. We start to notice more and more and more large synchronous call chains, and things start to reach tipping point. We start to see large cascading failures everywhere. The business may not be super happy that sometimes things are breaking and it's bringing the whole platform down with us. So what do we want to do? We want to start breaking out these asynchronous processes, build isolated systems and services in a really, really safe way. We want to make sure that when we're building something, the blast radius of it will be contained and small. If the new system goes down, that's fine. The core business over here, that's still up and running, and it's great, and everyone, I think, appreciates the resilient nature that this can build. So reliability and cost are features. They're quite often non-functional requirements. It might just be assumed that the system doesn't go down, but that doesn't happen by magic. We have to plan for that. So event-driven architectures can really help us do so by allowing us to build temporally decoupled, isolated systems. The isolation systems and the safety that we've got there help us to protect the revenue and the uptime in our services. If something fails in the back end, we don't have to send that error to the customer. We've already taken their request. We know what we need to do with it. We can present them an error to say, thank you, we're processing your request. And then in the background, we can recover and process it. We don't need everything to be running all the time. And of course, the cost is a key part to a lot of this. It's one of AWS's well-architected pillars. We need to think about how we're building costs for all of this. And event-driven systems, we only do things in response to something happening, means that we don't have systems running 24/7, I guess burning through money. We only run things when we need to run things. And empowers product teams to iterate quickly. I mentioned that EDA can empower technology teams to work independently of each other. They can also empower product teams to work independently of each other. We can build new products over here, not touching our core systems or services, and we can build them quickly. So we wanted to run our minimum viable migrations. I mentioned this already. We want to take something that's small, a single piece that we can change, and start there. We don't want big bangs. Big bangs cause bangs, and they're not good for business. So we take the small piece, and we want to change things single, one at a time. Find what we've got, start extracting the data out of that, and publishing the data. And then other teams can start to grow. And it really helps us build these evolutionary architectures. Things can always be changing and always be growing. And we find that we don't need to have our event publishers knowing who our consumers are. So I mentioned that extra bit of data at a time. We don't want to start publishing everything all at once either. Even if we do have that car sold event, we don't want to be putting too much information on that all at once. We're still a relatively small team, but we still want to have that strong human communication with everyone. We don't want our systems to know who their consumers are, but we want our teams to know who their consumers are. We want to build things and allow us to add data in a non-breaking way, and that roll-forward attitude to things. That if we need more data, then we can start doing so. We want to remove our temporal coupling. We want to queue requests up if we can't process them all at once. If we wanted to process everything as fast as we could everywhere all the time, we could stick everything onto a single giant EC2 instance, and that would be it. It would be expensive, and it wouldn't be particularly resilient. So we want to get into that thought pattern of having queues and distributed systems in place to remove the temporal coupling everywhere. And we really want to champion success. I can't say that enough, that we want to make sure that we're talking about this internally to make sure that teams are learning from everyone. Healthy engineering culture, again, helps empower teams, helps us move things forward faster, helps us experiment quicker, helps us grow the business even faster. So arriving at the destination. I've spoken a little bit about where Motorway were, some of the things that we've changed to do so, and some of the benefits that we'll get by doing it. But we've been cruising down the motorway. Where are we going to arrive? So I guess the tail end of last year, we started building our first new system in an isolated, independent, asynchronous, decoupled way. We wanted to build our instant match system, where we could allow people who have just sold their car to let us know they might want to buy a new one, and we could put them together with a car dealership who we know is selling that car to help build that relationship, hand it off to our dealer customers, and they can start the car sale process there. So we thought this would be a really, really good product for us to build, but we didn't want to build it on top of the existing services that we've got. It might be invasive code changes. It might be something that would be really, really hard to roll back if we didn't want to carry on building this service. And we wanted to make sure that we weren't slowing down the existing products that we've got. Putting more code from a new team into something that's already existing is going to distract the team that owns that service. There'll be code reviews. We'll have to build new monitoring and alerting systems. And we really, really did not want to impact the systems that are the main revenue drivers at Motorway. So we wanted to build it in an isolated way. We wanted to have as little scheduled jobs running as possible. We wanted to make sure this was becoming event-driven. It was only responding to car sold events and facts across the platform. We already had a lot of data getting published into an RDS database, so we wanted to lean on that RDS outbox pattern. We didn't want the existing code that we've got to have to write to the database and publish an event. We wanted to decouple those two processes, so if we didn't want to move forward, we didn't have to revert any code changes in our existing applications. And the rest of the system, I'm going to say system, the rest of the system didn't know that this new system existed. The teams did, but the applications didn't. There were no synchronous requests happening anywhere. There were no domain-specific point-to-point connections happening. It was all business process events, fact changes, car sold events that was powering it. So if you think back to the start, that typical system that I had, we'd have our two systems running with each other. There'd be some synchronous communication with them and some asynchronous communication with them. We didn't want to change any of that. So we wanted to lean on that outbox pattern that we've got. It would allow us to start publishing our events without changing our applications. So we've got our outbox worker reading from our existing database, and it's publishing it onto our event bus. Remember, we want to lean on the cloud as much as possible here and use everything that we can that someone else will give us. Got our fan. So everything's going into the event bridge, and we're then able to start fanning these events out to any application that may care about it. The first one was our instant match system, but this is also getting processed by our data teams and some of the other teams as we continue to build on these patterns. We can put it onto a queue. We don't want to be temporally coupled with everything. We want to queue everything up, put the requests onto a queue, and process it when we can. Perfect. We've got our compute. So this compute here, instant match worker, that's the first bit of application code that we have to write for this. We've got a lot of the moving parts that are already solved for us. We can push some of this information into a DynamoDB database. Great, the stream comes out the other side, and then we can start processing it in our instant match system. It can start sending these events, emails to people when we need to. Nothing on the left-hand side of this diagram knows that anything on the right-hand side exists. The teams knew they existed, but the people, the systems did not. And really importantly for us, it would be very easy if we wanted to remove the system completely, we just delete everything from the instant match queue to the right. Nothing on the left has to change. It allows us to build evolutionary architectures, iterate quickly, and start to build new business processes and products without touching the existing services that we've got. And being cost conscious, we want to make sure we're getting the best value for money as we can. We only pay for what we use. None of this, small asterisks next to any data stored in the Dynamo table, it's super cheap, but none of this costs us any money if we're not using it. We don't sell many cars at 1 a.m., so we're not publishing many events at 1 a.m. So everything over there has got almost zero underlying cost to it. The future, we've got to go somewhere in the future. So a lot of what I've spoken about already is what's got us to where we are right now, and we want to look ahead, the next mile down that motorway. We want to continue these minimum viable migrations. They've been a really, really positive benefit for us, extracting small bits of data at a time and allowing us to build those evolutionary architectures. We want to continue to isolate our systems and services based on our domains. We've identified a large part of those domains, bounded context and subdomains. We want to continue iterating on that and breaking these boundaries down more and building things in a more isolated way. The smaller our blast radius is, the more confidently we can change things quickly, knowing that it isn't going to take down large parts of the platform with it. We want to continue empowering teams. So I mentioned a few times that we don't want our systems to know who the consumers are, but we definitely want our teams to know what events that they're working with. So we want to make sure that we're building the correct monitoring, observability, and documentation tools for these. I think David mentioned his keynote earlier. Tools like Event Catalog can really help us in the future build these. I think we're very comfortable generally with building things like Swagger documentation with open API specs. We want to make sure we're doing the same with our event-driven architectures. And our events are APIs. Should not break our APIs. We do not make breaking changes in these, synchronous or asynchronous, something that we want to make sure we keep doing. So finally, a couple of the key takeaways that I think I would like everyone to try and take away here that event-driven architectures isn't just about technology. A lot of what I've spoken about is how we've changed some of our product, technology, and business processes and team thinking to evolve and build these evolutionary architectures. How they help us both save money whilst we scale, how they help us build evolutionary architectures and change our business processes in a confident way without risking a lot of the core underlying systems that we've got. The world is async. Everything that we do is asynchronous. If you've been leaving questions, we've been doing that in an asynchronous way. If you ordered coffee earlier, that's asynchronous. If you're hanging around later for some networking, that'll be a lot of asynchronous processes happening there. Everything around us is async. And EDAs help us build in a safe, scalable, and efficient way. We can pay for what we use only when we need to use it. We can build evolutionary architectures that are isolated away from everything else that we've got. And they allow us to grow and scale in predictive and well-known ways. Thank you very much.